If you've ever wondered why metals can conduct electricity or why they're so malleable, you're in exactly the right place. Today, we're breaking down metallic substances, what their structure actually looks like, why the properties of metals are the way they are, and the common misconceptions that tend to catch students out in exam questions. By the end of this video, you'll not only be able to describe the structure and bonding in metals, but you'll also understand how to explain those key properties like conductivity, malleability, and melting points. And don't forget, stick around to the end for a quick true-false quiz so you can test yourself and avoid those classic mistakes. Let's dive in with how to spot metallic structures. Now, the clue is in the name. Anything that is a metal has a metallic structure. And if you're thinking, well, here's a really weird random name of an element, how do I know if it's a metal or not? Well, quick reminder, you can use the periodic table. There is a separating line between the metals and non-metals. It starts underneath boron, and then it drops down one, across one, down one, across one, like a staircase. Anything that is on the left-hand side of that dividing line, those are your metals, and anything that is on the right-hand side, those are your non-metals. So everything there on that left-hand side, like 75% of the periodic table, are metals, and they have a metallic structure. Now let's focus on what that metallic structure actually is. So what we have there, and you can see in the simple diagram I've given you, are layers of atoms or ions. Now this is about the only place in structure and bonding at GCSE or A level where those two words are kind of interchangeable. Normally they are not. You have to be really specific with your wording when it comes to structure and bonding. The reason why you can use either here is because the metal atoms have actually lost their outer shell electrons, and those electrons are free to move. So because they've lost their outer shell electrons, you could consider them charged particles, i.e. ions. However, the overall metallic structure is still neutral. We have the same number of protons and the same number of electrons, which is why you can also use the word atoms. So layers of atoms or ions, I generally tend to go with the word ions, but it's fine if your teacher, your syllabus uses the two or a different one. And what we have is, rather than being joined together, you have a strong attraction between those layers of positive metal ions and the delocalized outer shell electrons. That is the metallic bonding, the strong attraction between those positive metal ions and the delocalized outer shell electrons. And remember, that word delocalized just means free to move. If you're not comfortable using the word delocalized, then don't use free to move. So these are the common mistakes. As we've just said, the metal ions and the electrons are not joined together. Instead, we have positive and negative charge there, and it is the strong attraction between them that is the metallic bonding. Secondly, not all of the electrons are free to move. So if we took, for example, lithium, which is element number 3, it has 3 protons and as an atom, 3 electrons. Not all of those 3 electrons are free to move. It's only the outer shell electron, which in this case for lithium, we'd have 2 in that inner shell and then 1 electron in that second shell. That's the one that's free to move. So we'd have lithium 1+ ions, and then the delocalized outer shell electrons, the attraction between those, that's the metallic bonding. Now, let's talk about properties. So the melting and boiling points we would describe generally for metals as high. There is one exception to the rule, really. So most metals are solids, hence a high melting and boiling point. The exception is mercury, which is liquid at room temperature. So that does have a lower melting and boiling point than expected for a metal. The reason why we overall have this high melting and boiling point comes back to that explanation we just went through. So lots and lots of energy is required to overcome the strong attraction between the positive metal ions and the delocalized outer shell electrons. Second property is conductivity. So conductivity means the ability of a substance to conduct electricity. And a reminder, and this is true across the whole of structure and bonding at GCSE Chemistry and A-level, put simply, for something to conduct electricity, you need something that can move and something that can carry a charge. There are two charged particles that fall into that box that could carry the charge, and those are ions and electrons. So here we actually have both. We have ions and electrons. So that's where the second condition comes in. Which one of those, the ions or electrons, are free to move? And in this case, it's the electrons. So we say, yes, metals do conduct electricity because the delocalized outer shell electrons can carry the charge through the metal. We then have two very specific properties to metals that we don't really discuss when it comes to other substances. Now, those words or properties are malleable and ductile. So as a reminder, the word malleable means something that can be bent or change its shape under impact. And for example, if I took a sheet of metal and I hit it with a hammer, it's going to change its shape. I'm going to put a dent in it. Ductile means can be drawn into wires. Now, these two properties, both malleable and ductile, can be explained in the same way. It's because they're layers, important word, layers of atoms or ions can slide relative to each other. They can slide over each other. And that strong attraction is maintained. So the ions and delocalized electrons are still attracted to each other. And finally, metals are insoluble, meaning they do not dissolve in water. However, important exception or something to recognize along with that, even though a lot of metals do not dissolve in water, some of them do in fact react with water. And you might know that, for instance, from your study of the group 1 metals, the alkali metals, they react quite vigorously when put in water. So we have high melting and boiling point, we have malleable and ductile, we have that they conduct electricity, and that they are insoluble in water. Now let's test this out. So as we have a look at each of these statements, see if you can decide for yourself whether or not these are true or false before I reveal the answer. Now remember, these are designed to catch you out. So really scrutinize the words and think, is this correct? Is it the right word in the right place? So first one, copper has a high melting point because there are strong forces of attraction between the nucleus of the copper atoms and the delocalized outer shell electrons. That one is, pause the video if needed, true. That one is true. And you might be thinking, but you didn't mention anything to do with the nucleus. But I did say we could use atoms or ions here. And we did say it's a strong attraction with the delocalized outer shell electrons. Those outer shell electrons are negative. They are going to be attracted to positive charge. That positive charge is the protons in the nucleus of the atom or ion. So that is true. Second one, copper has a high melting point because there are strong forces of attraction between the nucleus of each copper atom and its electrons. True or false? That one is false. It's false. There are two things that are missing here that makes this incorrect. So the first bit, see if you've spotted it, it's to do with the fact that it says and its electrons. Because remember, not all of the electrons in every atom are free to move. It's only the outer shell electrons. So the first tweak we'd make to that statement is outer shell electrons. The second thing to add in that really bumps you up to those higher grades, if that's what we're after, is to add in a large amount or a lot of energy is needed to overcome the strong attraction between the nucleus of each copper atom and its outer shell electrons. The third one, Metals conduct electricity because there is a delocalized electron. True or false? False. There isn't only one electron doing all of that work carrying the charge through the metal. Instead, from each atom or ion, there are delocalized outer shell electrons. So there's actually many electrons that are free to move. So that statement should actually read, for it to be true, something like, metals conduct electricity because there are delocalized outer shell electrons that can carry the charge. Next one. Copper has a high melting point because there are lots of strong covalent bonds to break. True or false? That one is false. There are no covalent bonds in metallic substances. The metallic bonding is that strong attraction between the positive metal ions and delocalized outer shell electrons. So that word covalent bond should be a flashing warning red light going off in your head there that it is not correct. And final one. Copper can be bent because the layers of copper atoms can slide relative to each other. True or false? That one is true. And if you wanted to make it even better, especially if you are doing or considering A-level chemistry, you'd add in whilst metallic bonding is maintained. Okay, let's sum up. So we've said that everything that is a metal on that left-hand side of the dividing line of the periodic table has metallic bonding. That metallic bonding is a strong attraction between positive metal ions and the delocalized outer shell electrons. We've also covered 5 properties: that they have a high melting point and boiling point, they can conduct electricity because of those delocalized outer shell electrons, they are insoluble in water, they do not dissolve, but some do react, and they can be bent into shape, malleable, drawn into wires, ductile.
Thanks for watching, and if you haven't already, make sure you hit subscribe for new videos every single week in GCSE and A-level chemistry.